All right, we've looked at adding and subtracting polynomials. Well, we looked at multiplication of them too. But now let's turn attention to a little bit of dividing polynomials. Guess we've done a little bit of dividing, but I wanted to show you just something a little bit different in the division of polynomials, like a tool, an extra tool that you can use to help you divide polynomials. So we'll be looking at dividing a polynomial by a monomial, and then dividing polynomials by divisors that aren't monomials. That's a little bit trickier. And then we'll look at this tool called synthetic division. Okay, first off, if you're dividing a polynomial by a monomial, like we did in the last section, probably the easiest thing to do is look to see if you can factor the top. In the top here, it looks like I can factor out an x, so I'm left with x squared plus 16x plus 6 all over 2x. Here I see that there's a common factor of x, which is a factor of 1, right? X over x is 1. So I can rewrite this as x squared plus 16x plus 6 all over 2. That would be a simplification of this expression here. Similarly, with this one, I could do a same kind of thing. I've got x to the fourth y cubed plus 10x cubed y squared plus 16x squared y all divided by 2x squared y. Look to see if you can factor something on the top. It looks like I can factor an x squared out and just a y, leaving me with x squared y squared plus 10xy plus 16 all over 2x squared y. Again, look for those factors of 1. So I have x squared and x squared, that's a factor of 1. Y over y, that's a factor of 1. So those can cancel, as we used to say, or it's a factor of 1 that I can eliminate. Now, my simplification then will be x squared y squared plus 10xy plus 16 all over 2. So that's dividing polynomials by a monomial, one term. Okay, easiest way is to factor the top if you can, and then look for factors of 1 that you can eliminate. Now, when we turn our attention to dividing a polynomial, my phone again, um, a polynomial by a binomial, then it turns into a little bit different trick. One thing that I could do is I could, like I did here, I could take that top thing, where's that phone? Sorry. I could take the um, I could take the top one and factor it and then look for common factors of 1. I could do that. Or let me just show you another way that we can divide. What you can do is you can write the division like this. So instead of writing it like this, I can write it as you would normally do a division. And here I'd go x into x squared goes x times, and then I multiply. X times x is x squared. X times minus 2 is a minus 2x. And then I'm going to subtract. Is this looking familiar at all to long division? X squared minus x squared is nothing. 3 minus a negative 2, boy, that's ugly. 3 minus a negative 2, that would be 5x. And then bring the 10 down. And then look to go x into 5x, that would go 5 times. And 5 times x is 5x. 5 times minus 2 is a minus 10, I think. Oh, I brought a plus 10 down here. I should have brought a minus 10 down. Okay, and then I have to subtract those two. 5x minus 5x is 0. Minus 10 minus a negative would be minus 10 plus 10, also gives 0. So when I divide x minus 2 into this expression, my answer, or my quotient, is x plus 5 with no remainder. And I could have seen that up here too. If I factor this into this, here there's a factor of 1, and so my answer, or my quotient, is x plus 5. Now, this long division, you can try a couple of those questions. Seems to be a little bit arduous, a little bit tough. This minus thing out here always seems to get me, that I get tricked on my minus signs. It's a little bit trickier. So somebody came up with something called synthetic division. And it's sort of doing the same thing as this, but it's simplifying it quite a bit. And here it is. Oh, that looks different. What you do is you take this here, I'm doing this exact division here. And what I do is I take the coefficients of each one of those terms, making sure that they're in order, x squared, x, and a number. If it was x cubed, it'd be x cubed, x squared, x, then a number. And if there isn't one of the terms, you have to put a 0 in for it. There might be some questions like that in the textbook to watch out for. So here I have 1, 3, and minus 10. 1, 3, minus 10. Then what I do is whatever I'm dividing by, my divisor, I take and I change that sign. So instead of a minus 2, it becomes a plus 2. Okay, so I change that sign. Okay, so then to do my synthetic division, all I have to do is bring my 1 down. That's a 1. And then I multiply and add, multiply, add, multiply, add, and just keep multiplying and adding until you're done. 2 times 1 is 2, and then add. 3 plus 2 is 5. 2 times 5 is 10, and then add. Minus 10 plus 10 comes out to be 0. Now, the way that I read this answer down here at the bottom is this part here is my quotient, and this part here is my remainder. Okay, so if this one started at x squared, then my quotient is always 1 degree less than that. So instead of being x squared, this one will be just simply x. So my quotient is actually 1x plus 5, or simply x plus 5. That's my quotient. And when I look at this same question that I did before, that is indeed what my quotient came out to. That's a little funny, isn't it? The synthetic division. It actually turns out to be a really useful tool to see whether a binomial will divide evenly into some other polynomial. A real useful tool to do that. Let's try one more, and then you can try some questions in your textbook. I'm supposed to divide this with synthetic division, okay? So out front, I'm going to write, instead of a minus 3, I'm going to write a positive 3. Draw a line and a line over. And then I just write the coefficients of each one of the terms, making sure they're in order. X cubed, x squared, x, and a number. Okay, so I write a 2, and then I write a minus 4, and then I write a 8 and a minus 8. Okay, I'm feeling good. First step, always bring that first number down. Then it's multiply, add, multiply, add, multiply, add, etc. 3 times 2 is 6. Add, that's 2. Multiply, that's 6. Add, that's 14. 14 times 3 is 42. Add, I get 34. Now this number here, remember, is my remainder, and this number here is my quotient. So if the remainder comes out to be a number other than 0, what that means is that this number, or this, doesn't divide evenly into this polynomial. Or in other words, this is not a factor because it doesn't divide evenly. Now, one thing I'd like to just show you too here, just to finish this off, is that anytime you have a division like this, you can write a division statement for it. And this is how it would go. The first expression is 2x cubed minus 4x squared plus 8x minus 8. Taking the results from my division here, I could say that this is equal to, the 3 turns into x minus 3. And this bottom stuff, since this was a 2x cubed, this will be a, right, 2x squared. 2x squared plus 2x plus 14 with a remainder of 34. Okay, so this would be called a division statement. So this could be rewritten as x minus 3 times this plus 34. If you ever see a plus 34 at the end there, that's indicating that there's a remainder and that these two are not factors of this polynomial. All right, so hopefully that gives you a little bit of practice doing some division. A little bit different dividing there, isn't it? Dividing the a binomial into a polynomial. And you can try some of those questions where you're doing the long division like this one, but I'd encourage you to practice this synthetic division lots. If you move on to other math courses, synthetic division is a key part of solving some polynomial expressions and giving you some characteristics about them. All right, try some questions, give us a holler.